Hi guys, we're looking at the 2019 O-Level A-Math Paper 1 Question 3. Now, we're given an equation involving some exponential functions here, and we are also given this equation. There's a dy dx there, there's a 4y there, and you have some exponential functions on the right. Now, what I'm going to do here first is I'm going to actually find out what is my dy dx, and then later sub in here. Let's find dy dx. Now, we all know that when we differentiate exponential functions, this is a unique function, whereby when you differentiate exponential functions, you get that same function back, just that you also have to differentiate the power. So differentiating ae to the power of 2x, differentiating e will give you e, and then when you differentiate the power 2x, we do get a 2. Alright, now moving on to the next term, be to the power of negative x. Differentiating that, we will get be to the power of negative x. Again, differentiating e to the power of negative x is just e to the power of negative x. And then when we differentiate the power, you get a negative 1. Alright, so this is your dy dx. Let's simplify this. Let's put the constant in front. So we have 2ae to the power of 2x, followed by a negative b e to the power of negative x. Alright, so dy dx done. Let's use this dy dx and substitute into this equation here. So I'm going to replace my dy dx with this expression, and I'm going to replace my y with this expression there. So let's do the substitution now. Okay, so this means that we have 2ae to the power of 2x minus be to the power of negative x plus 4y. Y is this expression here, and this is equals to e to the power of 2x minus e to the power of negative x. Okay, let's spend some time to observe what we have. Okay, so this is actually a skill that's important. A lot of times students just try to move on step by step without really thinking on their strategies. So it's a good practice to actually spend some time to observe what you have before you decide what to do next. Notice you have e to the power of 2x term here. We have somewhat like terms here, right? E to the power of 2x, and you have e to the power of 2x there. And again, you have another kind of term, e to the power of negative x. We have one there, we have one here, and we have one on the right. So what I'm going to do here is I'm going to simplify all my like terms. The e's of the same kind will be grouped together. But before we do that, let's expand these brackets first. So this one times this one will give us 4a e to the power of 2x, right? Plus another 2a. So that gives us 6a e to the power of 2x. Now, we have a negative b here, and this one we have positive 4 times b. So this makes it 4b minus b. That gives us a positive 3b. On the right-hand side, we have e to the power of 2x minus e to the power of negative x. So we've simplified whatever we can on the left-hand side. Let's do a comparison with the right. Okay, so comparing the e to the power of 2x with the e to the power of 2x, notice that, okay, there's no coefficient here. It's an invisible one. So we can safely say that by comparing this, right, we have 6a equals to 1. That makes a equals to 1 over 6. That's your answer for A. Okay, and then moving on to B, we will now compare your e to the power of negative x terms left and right. On the left, you have 3b. On the right, it's a minus. Again, there's an invisible one here, minus 1. So 3b would be equals to minus 1. That makes b equals to negative 1 over 3. And that's how we do it. Thanks.